All right, so in this section, this is the review for section 4.7, types of chemical reactions. Here we had already discussed a number of reactions. We won't go too deeply into them, but previously we had talked about the synthesis reaction. And remember, the synthesis reaction was identified with compound A or substance A reacting with B to form compound AB. And we had the reverse of that, the decomposition reaction. And that one was AB being decomposed back into A plus B. In both of these cases here, we could say that A was plus and B was minus, because that's what's going to be represented over here at the very end. And so likewise here, plus and minus, and then you would have those. The third type of reaction that we had looked at before was the single replacement reaction. And that was when you had a compound AB reacting with C. Here, C would replace A, so you would have CB plus A, and then here the A would have the ion charge there. And then the other type of the same one would be the double replacement. And the double replacement involved a compound AB reacting with compound CD. And here we would have C replacing A to form CB, and then you would have A and D identified there to be the other product that we would form. There was one other type of reaction that we had talked about in terms of the big five, and that was going to be the combustion reaction. And so the combustion reaction here would have been a hydrocarbon reacting with oxygen to form two compounds, carbon dioxide and water. And so these were the types of reactions that we had talked about before. And so if we separate these out, the two main type of reactions, or the three main types of reactions that we looked at here in 4.7 were the precipitation reactions. And largely it could have been any of these reactions that we talked about before. Essentially, the main thing that we're looking for here is a solid precipitate. So if we have a solid precipitate, that would essentially be a precipitation reaction. So the main thing you want to think about here is kind of think back to the knowledge that we had talked about in the net ionic section. So when we have the net ionic equation there, we were looking for the solid because that was the precipitate that was being formed. So make sure you're able to identify that. The other type of reaction that it's actually a bit bigger type of reaction is going to be the acid-base reaction. And this type of reaction was the one that we were concerned about because this is the one that was related to the titration, because these are also called neutralization reactions. And these reactions then are the types of reactions that are going to have the addition of a solid, or excuse me, the addition of an acid and a base. And just keep in mind here that when you have the acid reacting with a base, the end result here is going to be a salt plus water. And so this is an important piece of the acid-base discussion. And then lastly here, the other type of reaction that we need to talk about, which is the focus of the 4.9 section, and that's going to be the REDOX, or the reduction oxidation type of reaction. And the redox reactions are essentially identified with a electron transfer. And so we'll explore those here in the next section. Now, as we proceed in this section here with 4.7, the main thing we need to know about are how these proceed. And in the acid-base section, so that's the part that I want to talk about next. Just briefly, there were a couple of acid and bases types that you needed to know. So let's spend a little bit of time talking about acid bases so that we can actually refer to that here. And so in the general sense, the acid-base discussion, let's move this over here to the side, but in the general sense, the acid-base discussion has a lot to do with whether you are going to be producing ions of a very specific category. And remember, there were several of them, but here generally when we talk about acid, an acid was generally identified as a proton or a hydrogen plus producer. And then what we know as a base was known as a hydroxide ion producer. This is the contemporary view of an acid and a base. However, there are a couple of other definitions that we need to know about, and so generally here, we'll reserve that for the next section in 4.8 because we actually will go into a little bit more of, in that section here for 4.8, we'll talk a little bit more about the acids and bases in those types of reactions specifically. But generally here, before we move on, what you want to know with these types of reactions is that the reactions, there's a number of them already, as you can see, and specifically here moving in the acid and base. Remember, we'll talk about here pH is being as the negative log of the hydrogen ion concentration, and the pOH is going to be the negative log of the hydroxide ion concentration. And so we'll look at those here in the next section as we go further into the acid base. But generally, these are the types of reactions that we are concerned about in 4.7. So just make sure that you're able to go through and identify that. Another aspect of this section here is that you'll need to know charges. And so that's the main thing that I'll finish up here. So when you're looking at this idea, you want to be able to identify the charge. And so let me kind of bring this up a little bit, zoom in here. And identifying the charge of various compounds is really not a difficult thing. So for example, if we had a couple of problems here, we can give you something like MgCl2, and then you would need to come in here and identify the respective charges of these atoms here. So we know since the chlorine here is the negative side of the compound and the magnesium is the positive side of the compound, we can generally come in here and separate these out. And the idea is that since we've got two of the chlorines here, each of these chlorines has a -1 charge capacity, largely because chlorine is in group 17. If it gains an additional electron, it will have a -1 charge. So overall, on the negative side, we'll have a -2 total charge. We do need to make sure that we can juxtapose this alongside the positive side. So when we look at the positive side, some value here must be equal to 0 when we add it to the negative side of things. Now, if you do the math here, clearly the X value here is going to be a +2. And so we would know that the magnesium has a +2 charge in this particular case. So the general rules that you'll need to remember here to help you out figure out the charges is remember that any element in group 1 will typically have a +1 charge because there's a 1 valence electron that it can give. And in the next section here, in group 2, elements, any of those elements are going to have a +2 charge, largely because, again, here the valence count is 2, and so if it were to lose those electrons, it would have a +2. On the other side of things, so let's go to the other side of the periodic table, in group 17, these elements already are neutral at 17, but if they can accommodate 1 electron, so if it were to gain that electron, group 17 elements can gain a -1 charge. And for the same reasons, any element in group 16 can actually accommodate 2 electrons, and if it gains those electrons, it'll have a -2 charge. So that's something that's very important here in this section. And so you can see for the cations, these are for the positive side of things, and for the negative side of things here, for the anions, we'll have that. Now, the other item that you'll need to remember is when you have a couple of atoms that are both negative in charge, you want to make sure that you're able to identify which one of the two is going to have the overall charge. And so here's a very important tip. When you have two essentially nonmetals, the main idea here for who will have the negative charge, it's going to be the following. So when you have two nonmetals, when they combined, the atom with the more or the higher electronegative count will be the negative atom. So for example here, let's go and do an example over here on the far. Let's take this example here, and we'll do the following. So if we have something like, say, sulfur dioxide, if we do that example, SO2, the first thing is we look at sulfur, oxygen. Both of these would be negative because they're both on the non-metal side. However, which one's the more electronegative atom? And that atom is going to be oxygen. So when we actually assign which one is going to take the negative charge, the oxygen is more electronegative than sulfur, therefore it's going to be negative. And so here the oxygen is going to have a negative 2 charge per oxygen, giving it a total charge of -4, which means that the sulfur here is going to have to lose electrons. And when it loses those electrons, it will actually gain a positive charge. In this case, the charge of the sulfur is a +4. And so you should be able to go through and practice this type of identification of the oxidation charges for atoms for this section. So just be prepared for that. And then we'll continue our review here with the last section, or with the next section, 4.8, as we consider here the acid-base discussion.